Are you frustrated with Burp Community Edition throttling the speed of attacks in the Intruder tool? Let's fix that in today's video using the free Burp extension Turbo Intruder. If you're a Burp Pro user, don't click away. Turbo Intruder can actually be faster than even the unthrottled Intruder tool, so stick around because you might learn some things. Before we get started, welcome to my channel. I am Tiberius and I make web application security content here on YouTube. If you enjoy that kind of thing, please give this video a like, subscribe to the channel, and of course leave a comment with your thoughts. Now, some of you are probably thinking, why stick to Burp Suite? Why not use another tool like FFUF, WFuzz, or heck even Zap or Kaido? Well, those are all valid ways to perform fast fuzzing attacks, and there are plenty of videos on all of them. However, if you really like using Burp and want to easily send results from your fuzzing to other tools within Burp itself, then Turbo Intruder is worth a shot. The reason Turbo Intruder is so powerful lies in its configuration interface. It doesn't exactly have one. Instead, you control the operation of Turbo Intruder via custom Python scripts. This may sound daunting to you at first, but believe me, there are plenty of pre-built scripts out there to use, and in this video I'll show you 4 that I wrote, which mimic the 4 main ways of setting up a regular intruder attack. So let's jump right in. Alright, so let's quickly go over these 4 different attack types in Burp Intruder. So you can see here, this is the portswigger.net Burp documentation, and there's a screenshot here which shows the drop down that you see whenever you're setting up an intruder attack. So we have Sniper Attack, Battering Ram Attack, Pitchfork Attack, and Cluster Bomb Attack. So let's go through each of those and see what each does. So the Sniper Attack, this attack places each payload into each payload position. In turn, it uses a single payload set. The total number of requests generated in the attack is the product of the number of positions and the number of payloads in the payload set. Sniper Attack is useful for fuzzing a number of request parameters individually for common vulnerabilities. So really all that means is if you have 3 different positions in your request that you want to fuzz, let's say A, B, and C, then you can tag each of those positions in an intruder interface, and if you were using a sniper attack, you would just create one payload set. Now, a payload set is literally, you can think of it as a list of payloads or some kind of payload generator, right? So a list of usernames, for example. And the sniper attack would start off with the first payload position, that's position A. It would put each username in that list into that position, while keeping the B and C parameters the same. Once it sent all of those requests, it would then put the username into position B, and it would keep A and C at their default values, and then iterate through all of those usernames again. And finally, it would do the exact same thing with position C. So ultimately, if you had a payload set that consisted of 10 items, right, 10 usernames, and 3 payload positions, A, B, and C, the total number of requests being sent would be 30, right? 3 payload positions times 10. So the Battering Ram Attack also uses one payload set, but it does things a little differently. Instead of putting those payloads from the payload set into each payload position in turn, it actually will put them into each payload position simultaneously, okay? So the total number of requests generated in the attack is the number of payloads in the payload set. What does that mean? Again, if we have A, B, and C as our payload positions, and we have a list of 10 usernames, let's say the first username is admin, then the payload positions A, B, and C will all be set to admin in the same request. That'll get sent, and then we'll move on to the second username. And the second username might be guest. And so then A, B, and C will all have guest set as well. And that will iterate through until you reach the end of the payload set. So every single request, all the configured payload positions use the exact same payload. Now we'll move on to Pitchfork Attacks, and this attack iterates through a different payload set for each defined position. So now we're moving on to multiple payload sets, whereas the previous only had one payload set. Payloads are placed into each position simultaneously, so the first 3 requests would be in request 1, if you only had 2 positions, Position 1 would have the first payload from set 1, position 2 would have the first payload from set 2. In request 2, position 1, the second payload from set 1, the second payload from set 2, request 3, third payload from set 1, third payload from set 2. So what you can think about with this one is you're basically iterating through those payload sets simultaneously, right? And taking the same sort of indexed value of each and placing it into those payload positions. So this is kind of similar to the Battering Ram Attack, except instead of using one payload set for each position has its own payload set, but you still walk through those payload sets at the same time. So this is interesting though, because you might have a payload set in position 2, for example, that is smaller than the payload set in position 1. What happens when you run out of payloads in position 2? Well, luckily Portswigger tells us the total number of requests generated in the attack is the number of payloads in the smallest payload set. And that's important to know. So if your first payload set contains 100 usernames, for example, and the second payload set is 10 passwords, you're only going to be sending 10 requests. As soon as you reach the end of that second payload set, no more requests are being sent in this Pitchfork attack. And finally, we have the cluster bomb attack, which I feel like is one of the more common attacks that people set up in Intruder. Super useful if you're trying to do brute forcing of any kind, really. This has different payload sets for each defined position, but payloads are placed from each set in turn so that all payload combinations are tested. Okay, so let's imagine we have a username list and a password list. In position 1, you use the first payload from the usernames, and in position 2, the first payload from the passwords. But then in request 2, you're still using the first payload from the usernames, and now you're using the second payload from the passwords. So effectively, we're keeping the username the same and iterating through each of the passwords in that password list. Once we reach the end of the password list, we then adjust and we use the second payload from set 1, i.e. the second username, and then we use the first payload from set 2 again, the password. So in this case, we're going to basically iterate through all the usernames with all the passwords so that every single combination of username and password is sent. Like I said before, very useful for brute forcing. The total number of requests generated in the attack is the product of the number of payloads in all defined payload sets, which may be extremely large, right? So in this example, if we just have 2 positions, if we have a username file and a password file, say the username file is 100 usernames and the password file is 100 passwords, that's 100 times 100, so that's going to be 10,000 requests. Now imagine that we just introduced one more position, right? Position 3, which again, we give it a file that has 100 values of some kind. Now we're talking about 1 million requests. But in this case, we can keep it to 2. And, as long as the payload sets are small, it doesn't really matter how many positions you have. You can have quite a few positions as long as everything is small. Or if you have a couple of positions, the payload sets can get relatively large. It just depends. Burp will actually calculate how many options you have if you're using regular Intruder. So yeah, it's useful for very, very focused brute forcing attacks, but just be careful with it. Okay, so what I've done here is I have actually programmed a very, very simple Flask application. It has one endpoint /hack, and it takes 3 parameters, A, B, and C. And if I click send, we get a message, which is fail. Now, there are 3 specific values for each of these parameters, which will trigger some kind of success message, but we're just going to use each type of intruder attack within Turbo Intruder and just see what we can do, how we can set these up, and how to use Turbo Intruder to kind of emulate what we really want to do with regular Intruder. But how do we install Turbo Intruder? Well, we can just go to the extensions here. We can go to the BAP store, and we can either use the search. I'll just type Turbo, and we get Turbo Intruder here. You can scroll down and click install, which will be this button here. You can check that it's installed by going to the installed menu here. There should also be this menu item at the top here, but it doesn't have a separate tab. You'll know though, if we go back to repeater and right click on this request, go to extensions, Turbo Intruder, and send to Turbo Intruder. I'm going to maximize this now. So when you send a request to Turbo Intruder, you'll see you'll get this window appear. It has this pane at the top. This is the request, and here is where you would put your Python code. And you can see here we have this drop down, and there are a few options already built into Turbo Intruder. Basic.py, examples/basic.py, is a super basic fuzzing script which will fuzz one position in the request. So let's talk about how we tag positions in Turbo Intruder. It's actually pretty simple. So we have 3 positions, A, B, and C, and the position is actually the value of A, the value of B, and the value of C. So in this case, 1, 2, and 3 are the actual payload positions, technically. So what we want to do here is replace this 1 with %s, replace this 2 with %s, and this 3 with %s. And that's all we need to do. You just use %s to tag 3 different positions. If you only have 2, obviously just use 2. If you only have 1, use 1. You tag as many positions as you want, and then what happens is you need to adjust your script accordingly, and we'll do that right now. So what we're going to try and do is the sniper attack. And I already have a script coded for the sniper attack, and I'm going to copy it now. Okay, so there's a few things we do here. The first thing we do is we import URL lib. We need to do this because we need to URL encode these values. So Turbo Intruder does not do any URL encoding by default. It doesn't do any encoding by default. So you need to do that manually. So that's one limitation of Turbo Intruder. The other thing you'll note is you have this queue requests function, and this is basically where all the magic happens in Turbo Intruder. This is where you do all of your payload processing. We also have the engine. You don't really need to tweak this too much. You can leave most of these settings fine. The two that you might want to tweak are concurrent connections and requests per connection. So all this means concurrent connections 5 means that Turbo Intruder will open 5 separate actual connections to the web server. At all times, it'll have 5 open, and the 100 here request per connection means it will send 100 requests down those connections. So you can increase either of these values and it should speed up the attack, okay? But generally speaking, 5 concurrent connections and 100 requests per connection are usually fine, okay? But you can play around with these. The one thing we do need in the sniper attack specifically is we need to define default payloads, okay? And effectively, this is going to be a list of default values for every single payload position that we have. We've defined 3 different payload positions, so I need 3 different default payloads. And I'm just going to set them to the original values, right? So remember we had A equals 1, B equals 2, C equals 3. So here I've set 1, 2, and 3. And note they're strings because everything in a request is technically a string, right? Even though these were integers, there is no concept of an integer in an HTTP request. It's all just string data, kind of, right? And those are required because remember, in a sniper attack, you're only using one payload set at a time, right? So when we're iterating over the payloads for the first position, for position A, we need something to put in position B and C, and that's going to be these default payloads. So what we do is I set up an iterator, so we're basically iterating over each of these payloads, so the payload positions, and then I'm opening this word list, wordlist.txt. Open will open this file, and then if I put it into this for loop, effectively every single line of this file is going to be assigned to the variable payload in turn, and then we can use that payload variable within the for loop. Next line might look a bit confusing. All we're doing here is we're creating a complete copy of default payloads and setting it to the variable positions. We need to do that so we don't mess around with the default payloads as we're doing this. It honestly is just a little easier. But this syntax just makes an actual copy of that rather than referencing it. Because if we did it any other way, if we just set positions equal to default payloads, anytime we change positions would be changing default payloads. It would be kind of chaotic. And then what we're going to do is we are going to set whatever value of I. So remember, we're iterating through these default payloads in turn. So in the first iteration will be on this first payload, right? 0, position 0. So we're going to set the 0 position of this copied list to whatever the payload, right? The current payload is. We're going to strip any white space from it, okay? Because technically we're reading from a new line separated list. And then we're going to use the URL lib library and the quote function to basically make this URL encoded. Then we're going to use engine.q, target.rec, and then just pass it positions. And this is literally the list here, right? That's all the code you need for the queue requests. That will iterate through effectively all different payload positions, and then it'll iterate through all payloads and put them into each position in turn. Now we have this handle response function, and this is really important that you make sure this is going to be looking good. Handle response is the way that Turbo Intruder knows what to show in the results and what to not show. And in this case, let's just check the status and make sure it's not equal to 404. All right, so we're just going to ignore any 404 responses. And for any that don't match 404, we're going to add them to the table. And that's it. For most of these, you can leave this the same. You may have something that you want to add here, but it's basically just a simple if statement. Currently available attributes are request.status, request.wordCount, request.length, and request.response. Okay, so you can actually do quite a few things with these if conditionals, but we are going to keep it pretty simple for this video. So let's click attack and see actually how this works. Okay, so you see it did it quite fast. It sent a total of 15 payloads. That's because I believe the word list I used only had 5 values. And you can actually see here we have 5th, 1st, 4th, 2nd, 3rd. Remember, this is concurrent, so even though this list I believe is 1st, 2nd, 3rd, 4th, 5th, like literally the words, that might not be the order they appear in these results. So in this case, the first request that we have here is the payload 5th, and then obviously 2 and 3. Then we have 1st, 2, 3, 4th, 2, 3, 2nd, 3rd, and then we move on, right, to the 2nd position. So now A is now always going to be set back to 1, its default value, and we're going through B. So we have 1st, 2nd, 5th, 3rd, 4th. Again, the order might be a bit chaotic, but then we go through the 3rd payload position, right, C. So now A and B are both set back to their default values, and we get 1st, 2nd, 3rd, 5th, 4th. Okay, so that's that script. That's how you would do a sniper attack in Turbo Intruder. And now we can click Halt and Configure, and we can go back. And let's do a Battering Ram Attack now. So I have another script. I'm just going to copy in. Okay, we're going to leave everything the same up here, because ultimately these aren't going to change. We are fuzzing the same payload positions each and every time in this. We're just going to change the script. And this is the battering ram. So this is going to be a single set of payloads. So we're using this wordlist.txt, which contains, remember, that 1st, 2nd, 3rd, 4th, 5th as words. But this time it's actually a bit simpler, because all we're going to do is we're going to switch up how we iterate. And instead of iterating over these range of payloads here, we're actually going to iterate over the word list, and then we're going to assign every single word in that word list to all of these payload positions at the same time. Okay, so A should be set to 1st, B should be set to 1st, and C should be set to 1st in the first request. It might not work out that way, as we've seen. It might be 5th, 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 but we'll see. So the code is pretty simple. We define the payloads this time, and then we're iterating over the word list. We iterate over the range of the payloads, and then we're going to do some position handling here. So we're basically taking the index of each payload here, and again just setting it to the URL lib quoted payload, which has been stripped of its new lines. We're just going to pass the payloads list into this engine.q function. Again, this is all pretty standard for Turbo Intruder. The handle response function is exactly the same as before. And now if we click attack, instantly we get some nice responses. So again, ironically, 5th did come first. So again, we have 5th, 3rd, 2nd, 4th, and 1st. And the reason 5th comes first in this case, I mean, it's not always going to do that, but that's because, remember, if we go back to this configuration, we have concurrent connections equals 5. If I change this to 1, then the order is actually going to be fine, because it does send the requests. So Turbo Intruder does send the requests in order. It's just in the previous case we had 5 concurrent connections, so it was basically potluck which one was going to return first. Okay, so moving on, let's use the Pitchfork Attack, which, if you remember, is going to be using multiple sets of payloads, but it's going to iterate through them in a kind of battering ram way, right? So it's going to be taking the first payload of the first payload set and putting it into position A. It's going to be taking the first payload of the second payload set, putting it into position B, and the first payload of the third payload set and putting it into position C. And it will just walk down those lists, those payload lists, right, until it reaches the end of one of them. That's the important thing to remember. So this is where the script gets a little more complicated. So the 3 types of payload set that I chose, we have this just an array of usernames, right? A list of usernames: root, admin, administrator, user, test, support, and guest. So this is 7 different usernames. This is just to show that you don't need to read from a word list. Okay, we're just going to read from a actual list in Python. The other payload set we're going to use is actually that wordlist.txt file again, right? So we're going to open and read it as file 1, and slightly different syntax just because we aren't iterating over it as we normally would. And the third payload we're going to use is actually this range function. So the range function is going to generate a list of numbers between 0 and 10. It's not actually going to include 10, so it'll technically just be 0 to 9. But it'll be 10 numbers. Remember, we have 5 payloads in here, 10 numbers here, and 7 usernames. So if this does work, we should only get 5 requests, because once we hit the end of wordlist.txt, that should be it. How did I get it to iterate through these payload sets simultaneously? Well, I used the zip function. And so what you can do with the zip function is give it these 3 different types of iterator, technically. So we have this file object, we have the usernames list, and we have this range. And if we pass these to zip and then use them in this for loop, we can actually extract 3 different variables: payload 1, payload 2, and payload 3. Payload 1 will be the first item in file 1, payload 2 will be the first item in usernames, and payload 3 will be the first item out of this range, which is going to be 0. We can then URL lib quote them. Okay, so in the first 2 instances, for payload 1 and payload 2, they're both going to be strings, so we need to strip them of the new line characters. But for the third payload 3, this is actually going to be an integer because we're using range, so we do need just to convert it to a string here. And then what we're going to do, we're going to use engine.q again. Instead of, we obviously don't have any kind of list of payloads here, but we can just create one, right, with square brackets. So this is just a list of payload 1, payload 2, payload 3, and we're just going to queue that request up. So slightly more complicated. Hopefully I've explained it okay. If you look over the code, it does kind of make sense. And I tried to make the code as understandable as possible, but if you have questions, leave them in the comments. We then just have the handle response function, exactly the same as before. So let's click attack now. And again, yeah, there you go. We only got 5 requests. And let me actually go back, let's rerun that, but we'll set the concurrent connections down to 1, just so everything's in order, because order's nice, right? Okay, so the first request, it did indeed use the word first, and then root, which was the first username, and the number 0. Then the second request used second, the second username, which was admin, and 1, the third administrator, and 2, fourth user, 3, fifth test, 4. Okay, so as soon as it hit the end of that first word list, right, because the first word list was the shortest, then it stopped. And we can actually see that. Let's make this usernames list only 3 long, right? Only 3 usernames, root, admin, administrator. Now if we do, we only get 3 requests sent, because as soon as we reach the last payload in any payload set, the attack is just gonna stop. Okay, so finally we're gonna move on to Cluster Bomb. And Cluster Bomb is actually kind of easy code to write because you just have to keep iterating, right? It's every single combination, so as long as you just keep embedding for loops or while loops or whatever you're using to iterate in each other, you should be fine. So you know what we'll do? We'll keep current connection to file because this is going to be a lot of requests actually. Usernames, we have the same usernames list. We are using the wordlist.txt, setting it to file 1. And then all I'm doing here is I have 3 different for loops. So for payload 1 in file 1, effectively reading each and every line from the file wordlist.txt, assigning it to the variable payload 1, and then inside that for loop, for payload 2 in usernames, iterating through each of the strings in this usernames list, okay, assigning it to payload 2. Inside that for loop, there's for payload 3 in the range function, range 0 to 5 this time, just to keep things a little easier, because if I do 0 to 10, it's going to be a load more requests. So we're only going to iterate through the numbers 0 to 4 inclusive. And within this final for loop, because we only have 3 payload sets, 3 payloads, we're going to do the same thing where we're going to assign each one again. We're going to URL lib.quote payload 1. Again, we're going to quote payload 2 because these are both strings. Payload 3, we need to convert right to a string because it's technically using this range function, which just creates integers. And we're going to URL lib quote that again. We don't technically need to do that because it's just numbers, but whatever. It looks kind of nice, right? And you may, switch this out. So I wanted to try and keep everything as simple as possible, I guess. And again, we need to rebuild the list of payloads here. So every time we send a request to the engine queue, we need to give it the entire list of whichever payloads in order. So payload 1, payload 2, payload 3. And again, handle response, exactly the same. But now what this should do is create quite a few requests because we are iterating over a word list containing 5, a username list containing 7, and another range containing 5. So if we do that, look at that, we get all these lovely requests. How many is it? 175, I think, total. Yeah, 175 because we start counting from 0. And look at all this. So first root 3, first root 2, first root 0, first root 4, first root 1. So every single combination of all of those payload sets, right, gets sent. So yeah, if you were doing brute forcing using usernames and passwords, this would be how you could do it here. And just look at how fast that all returned, right? That was pretty much instantaneous. It's definitely faster than regular Intruder. It's almost faster than regular Intruder when you're just running it in Burp Suite Pro a lot of the time, like especially for basic stuff. So this is definitely worth looking into, especially if you like using Burp Suite, because you can just right click, add to sitemap. You can right click this request, send it to repeater, right? So you can do a lot of stuff because this is integrated into Burp Suite itself. You can use this stuff. And actually what we've noticed is every single response has been a 400 bad request, right? So let's rerun that. We don't care about 404s. Let's only care if the response doesn't have a status of 400. So let's see what happens there. Instant, right? We get a hit, a status of 200 this time with the message hacked, and the payloads, 3rd, admin, and 4. And those were the actual payloads that I chose when I was coding the application to give some kind of positive result, right? So this, effectively, we brute forced the solution to the puzzle that I set myself and I knew the answer of, but whatever, just shows what you can do with Turbo Intruder and how fast you can actually do it. Thank you so much for watching. Hopefully you now feel a little more comfortable using Turbo Intruder within Burp Suite. If you learned something from this video, please consider giving it a like, subscribing to the channel for more web app security content, and of course leaving a comment to let me know what you thought. If you have questions about Turbo Intruder or want to see something a little more in depth, let me know too, and I may do a follow-up video. Until next time, happy hacking!